Okay, so again, if they present the problem to you like this on the left and you look at it and say, hey, look, x squared plus 5x plus 4, that factors into x plus 4 and x plus 1. Okay, right? And I can say, oh, look, I have an x plus 4 on the bottom. That works out too. I can do cancel, cancel, and that's an answer, right? Another way of looking at that is instead we can look at this and put it into a long division problem. So let's try this same problem. We know that we should get an x plus 1 with no remainder using the old method. Let's see what happens with the new one. So again, I'm going to look at this and say my first term here is x. How many times does x go into x squared? Well, I have to bring in an additional x, right? I'm trying to get that first term to cancel using my x. X times x is x squared. Okay, x times 4 is 4x. Okay, and remember, this is a subtraction problem. Okay, so this is going to be, okay, x squared minus x squared is gone. 5 minus 4 leaves me with 1x. Bring down my next term, plus 4. Okay, how many times does x go into x? Well, it goes in one time. Okay, and I'm going to make one minor adjustment to something that I did up here. We want to be consistent. When I found the x times, I'm going to put it over top of the same term, right? And so now I can say, how many times does x go into x? Well, it goes in one time. And when I multiply it out, 1 times x is x. 1 times 4 is 4. Okay? And again, when I subtract, I end up with 0. No remainder. Everything cancels. So if you notice, the same x plus 1 that I got using factoring and canceling, I also got using polynomial long division. Okay, so that's a very quick, simple example of you're allowed to use either method and it will work. Okay, so let's look at one more problem, most challenging of them, right? And I'm going to show you everything that you're going to see. Okay, so in this case, here's what I'm asking. I'm calling this function f of x, okay? And then I'm asking you to write the answer, which they're going to call q of x. Q stands for quotient, right? Quotient is what is the answer, okay, to a division problem. So I'm basically saying, here's a problem I'm asking you to divide. You're going to give me the answer plus, okay, the r is the remainder, okay, and the d is the divisor, right? So I'm basically asking you to divide this and set it up in this format, quotient plus remainder over divisor. So first thing we need to do is make sure we get this information that's set up as a fraction and put it into the long division symbol properly. So remember that the first number up top is what goes inside. Right, so I'm going to move the 3x cubed minus 2x squared plus 7x minus 4 on the inside, and then the x squared minus 1, what I'm dividing, that goes outside. All right, so let's take a look at how we do this problem now. So we're going to say, how many times can x squared go into 3x cubed? Okay, well, what we're going to look at is say, how I basically want to complete this 3x cubed. In order to do that, I need a 3 and I need an additional x, right? So I need 3x in order to complete this. So here's what I'm going to do. The 3x is going to go over the 7x, right? Try to line up all your expressions, okay? And I'm going to say 3x times 3x squared is 3x cubed, okay? 3x times 1, or negative 1, is going to be negative 3x. So just be careful. That goes underneath the 7, right? Because it's not an x squared. When I do 3x times 1, I get 3x. So I need to, again, line it up. So here's my subtraction. Okay, negative 2x squared has nothing to, it's got 0 in here, so that's still negative 2x squared. That'll come down, right? They'll just fill in that space. Okay, and 7, again, you got to be careful. 7 minus, this is all subtraction. Okay, in order for 3x cubed and 3x cubed to go away, I need to subtract them, which means I'm subtracting everything else. I'm doing 7 minus negative 3, which is actually 10. Okay, so you have to be really careful when you're subtracting negatives, okay, that you actually don't forget about that 1 on the left. All right, so now we have the first term. I need to bring something down. I need to bring down this minus 4. Okay, so I'm going to bring down the minus 4. Okay, and we're going to do the same thing. We're going to say, how many times do I have to what do I have to put here in this next position so that I will cancel out this negative 2x squared? Well, it looks like we have all the x squareds we need, right? I have x squared out here. I need x squared, so I just got to bring in a number, okay? And in this case, that number is just going to be 2. Okay, so let me get rid of that blue, right? And I'm going to say plus 2, and let's find out what happens. Okay, 2. I'm sorry. Let's make it the same thing. Minus 2. Okay, the minus 2, okay, is going to make it match, and that's what I'm trying to do. Negative 2 times x squared is negative 2x squared. Okay, negative 2 times negative 1 is going to be positive 2. Okay, all right, so let's do our subtraction and find out what happens. Again, there's a subtraction sign out here. -2 minus -2 cancels. Okay, 10x is just going to come down, right? 10 minus 0 doesn't change anything. -4 minus 2. Well, -4 minus 2 is going to be a -6, and that's my my problem. I have nothing else to bring down, right? I can't go any further. X squared cannot complete an x. It's already too big, right? So it's kind of like, again, let's go back to the simple number problem. 14 was bigger than 12, and that's how I knew to stop. I couldn't go any further because 14 doesn't go into 12 at all. In our problem here, okay, x squared is bigger than x, right? So I can't take x squared into x any times at all. That's as far as it goes, right? So this right here, 10x minus 6, that's my remainder. Okay, that's like the 12 that showed up here. It was what was left over after I brought down the last term and divided and couldn't go any further. Right? So what we're going to say, here's my final answer. Okay, I'm going to say, after all said and done, the answer is 3x minus 2. Okay, that's like my q. That's my q of x, my quotient. Okay, and to that I'm going to add the remainder, which is the 10x minus 6 that I was left with. Okay, 10x minus 6 over the divisor, which is x squared minus 1. Okay, so I'm going to say this is my final answer. That's the best I can do. I got a full 3x minus 2 to divide evenly into this expression, but there was some portion left over. There was a remainder, and in this case that remainder is 10x minus 6. That was what was at the bottom, over my divisor x squared minus 1. So I know you're probably looking at this and you're saying, you know what, that was really complicated. That was a lot of work. We're going to spend a lot of time doing a lot of practice with these problems, and you will slowly pick up all of the details and get used to where everything's got to go and how to subtract properly without making any mistakes. Okay, so you'll see a lot of this tomorrow, and you'll have a lot of opportunity to ask questions and do practice. So just make sure that you have a somewhat of a handle on what we just did, and we'll discuss it more when we get into class tomorrow.